All right, folks, welcome to this virtual weather and climate office hour. This one's going to be talking about some remarkable and even record breaking, and I mean that in a very literal and superlative way, record breaking warmth in March to come. So, on top of what is now confirmed to have been a record warm winter across much of the American West, including much of California, we're now headed for a period in March that will feature not only spring like warmth, but actually peak summer like warmth in some locations, with temperatures pushing 100 degrees or even exceeding it in some parts of California and the Southwest that have never before experienced triple digit temperatures this earlier in the year. I will remind everybody that it is, in fact, still the first half of March. Keep having to check the calendar every time I go outside in a t-shirt this winter, and that's been true wherever I've been in the American West in the last few months. I've been in Southern California, Northern California, and Colorado, and places in between, and it just hasn't been cold in a way that you would typically expect for the winter. For almost this entire season. Yes, there have been some individually cold days, but overall, it's been, well, for lack of a better word, kind of ridiculous how warm it has been and how conspicuously not cold it has been. That, for me, has actually been more unnerving than the warmest daytime high temperatures has actually been the near total absence of significant and especially sub-freezing winter cold. And that's not just true in the lower elevations in California, but is even true in the mountains, the Rocky Mountains, the Sierra Nevada, where temperatures, yes, they've been below freezing, but not for very long and not very frequently this winter. And again, I will once again reiterate that meteorological winter has ended. We did not get that any of those severely colder periods that we would typically expect. And although it can still snow in the western U.S. mountains, of course, in March and April, it certainly isn't going to snow in the next couple of weeks, and I'll show you why. And once we get toward the end of March, that is usually viewed as the effective end of meaningful snow accumulation, and that might be especially true this year given how warm it is. So we are in a fairly serious situation across the interior West, especially. There was already a crisis in the Colorado River in terms of long-term water deficits and the severe multi-decade drought that has pervaded there for decades. Now the problem is we're going to put an exclamation point on top of that Colorado River basin challenge with record low snowpack, record high temperatures to end what was already a pretty terrible winter, upper and lower Colorado basin. And now in California, it wasn't so dry. We had a reasonably wet winter in much of the state, especially in Southern California, where the season ended up well above average despite recent record dryness. But where the snowpack, it never really reached its potential even at the peak of the season and is now declining precipitously in advance of what will likely be a record-breaking and prolonged March heat wave in the mountains. So whatever the snowpack is now in California, Arizona, Nevada, Utah, Colorado, Oregon, it's going to look a lot worse a couple weeks from now rather than better. So a lot of folks like to talk about the notion of a miracle March. This was a term coined to describe essentially the saved by the bell effect, if you will, the fact that sometimes, even in a poor winter water-wise or snow-wise in the American West, you can have a single month on the back end, namely in March, where there is a great deal of recovery, where a dry winter turns into a not so dry winter thanks to a series of very wet winter-like storms, or a not very snowy winter turns into a far snowier one because of cold and or wet conditions in March. This year, that is not going to happen. There will be no miracle March. It's very clear at this point, looking forward from the 10th of March, what didn't happen in the first 10 days of the month and what almost certainly won't happen in the last 2/3 of the month. We're going to get to April 1st and we're going to have some scary snowpack numbers essentially everywhere. scarier in some places than others, but nowhere good in the American West. And I'll talk a lot more about that later. But the other thing I do want to emphasize here is that we are about to experience the hottest March temperatures that we've ever seen across a lot of the western U.S., in particular the Southwest, the interior Southwest, and parts of Southern California. This is going to be a heat wave that people aren't going to be able to ignore because of when it's happening. In fact, some places will probably see temperatures that might exceed the typical hottest temperature in a moderately cool summer over the next couple of weeks. So places that don't even see 100-degree temperatures every year might experience them in the next 10 days. And that includes highly populated parts of the Southern California coastal plain, including parts of LA, which could in fact hit 100 degrees or come very close to it in just a few days, and potentially again next week. This is not going to be a short duration heat wave. It looks like it's pretty much going to last for the foreseeable future. Looks like it's going to be a 10 to 14 kind of day stretch of extraordinarily anomalous weather. It won't be equally hot the whole time everywhere. It will kind of shift around the peak maximums a bit around the west, but it just looks, again, really extraordinary. And it is quite likely that many cities and probably many states will set new all-time March high temperature records, as well as new records for the month of March cumulatively overall, but also the individually hottest temperatures, all the way from Colorado to California. I think we're going to hit records everywhere in between there as well. So yeah, quite a situation. I'll get into it more in just a moment. Just want to remind everybody that if you do want to be reminded of when I have these live streams, and they're often focused on real-time events, topical sessions. Sometimes I have Ask Me Anything type sessions, but typically they're more focused on the topics of the day, like today's session is. Please do subscribe to the channel, because that's the fastest way to be notified when I go live. Just remember to turn those notifications on. And a reminder that this channel is sponsored by Reask, a climate tech company that's helping to rethink extreme weather risk in a warming climate. Seeing plenty of that these days. All right, so I'm trying to decide what data I want to share on screen first, because I have a lot. Well, let's start, well, as they say, at the beginning. And you'll see my screen for a moment, and then we're going to transition over. I talked about this last time, so this shouldn't be a great surprise to anybody who's been following, but this past winter was officially now the warmest on record for the vast majority of the American West, including much of California. It turned out that it didn't quite make the threshold for the single warmest winter on record for the state of California on the whole, because those of you in the Central Valley already know what I'm going to say, because those Thule fog weeks actually helped keep the state top line number down just enough that it wasn't quite able to eclipse the winter of 2014-2015. If you remember how crazy that winter was, though, that's a pretty high bar to beat, and we effectively, statistically, tied it in California. But this winter actually was warmer in coastal Southern California. So we're talking Ventura County, Santa Barbara County, Los Angeles County, San Diego County, as well as the Sierra foothills and High Sierra. So South Lake Tahoe, Reno, all of these places were generally warmer this winter than even 2015 and experienced new records. And you can see this on the map of places where the last 4 months were record warm. Anywhere in bright red was the single warmest such period over a four-month window in at least 131 years, the longest period for which we have records. It's, again, almost everywhere. The whole state of Arizona, the whole state of Nevada, almost all of Utah, almost all of Colorado, almost all of Wyoming, most of Idaho, most of Oregon, most of Washington, most of Montana, most of Kansas, most of Nebraska, most of Oklahoma, and much of Texas. I went through that list exhaustively because it is exhausting. It's extraordinary, and I really think it does bear emphasis. I also want to point out just all of those news articles, the breathless news articles about how cold winter 2025-26 was in the eastern U.S. are referring, I just want to point that out, to this area. So compare this to this. They are not by any means equal and opposite. Not only are they not equal in the size of the anomaly, spatially speaking, that's pretty obvious, but look what this past winter ended up looking like. We did get into below average territory in some spaces, but nowhere much below average, let alone record coldest. And in fact, when we see some of these places, we think about New York City, for example, and the area near some of the largest population centers in the country. New York, for example, this winter was the 51st coldest in the past 131, so barely cooler than average. Even we go to upstate New York, we're talking about 25th, 28th coldest. And in some parts of the South, which did experience major cold snaps, this winter was actually still warmer than average overall. The numbers change a little bit if we go to the last 3 months. So this is a 4-month map. This is going back from November to February, so a longer period. We go for the shorter period, and the map changes a little bit, but not really in substance. It's still the same overall picture. Extraordinary warmth in the west and very modest coolness in the eastern quarter of the country, but that's completely out of balance here. And some of the places, just to show the magnitude of the anomalies, exceeded average by, again, as I mentioned last time, really just kind of phenomenally large margins. I mean, we're not above average by a few degrees. We're above average by 5 to 10 plus degrees Fahrenheit for the whole winter in some places. And I'll remind you again, as I pointed out last time, this is relative to our already climate warmed baseline of 1990 through 2020. So this isn't even accounting for the climate change that occurred prior to 1990. This is sort of baking that warming into the equation. So if you were to compare this to the 20th century, this map would actually be even redder in the west. And that's really kind of all I got to say about this one. Again, a reminder that the last 3 months, and this is actually probably better if we go the last 5 months to do for the water year. So we're now talking October through February. Again, record warm throughout a lot of the west. It looks a little bit different in California, but it actually extends farther east. What I really want to show, though, is precipitation as well. So record warm, and in the west, not necessarily record dry. You do not see, except for a couple of places out in northeastern Colorado, for example, so the Denver Boulder area where it was really dry, and then some parts of Utah, this was not a noticeably dry or wet winter overall. It was actually fairly close to average in a lot of places, except for Southern California, where this winter was, in fact, among the top 10 wettest on average. LA County, let's see here, the 9th wettest winter on record in LA County, Ventura County, 10th wettest on record in Santa Barbara, and in Kern, the 7th wettest as well. And by winter, in this case, I mean water year to date, so October through February. Reminder also that if we looked only through December, what we would have found, again, is that we had the wettest start to the water year on record in Southern California. So again, the single wettest start to the season on record in LA, Ventura, Santa Barbara, Kern counties. If we extend it to the full water year to date through the end of February, we retain that relative wetness. Northern California, generally not as wet, but closer to average. So when I'm about to show the snowpack map, remember, this is mainly being driven by extraordinary and even record-breaking warmth rather than a lack of precipitation. So here is that snowpack map. And I keep showing this because it keeps showing alarming things. But here, again, you can see here any of the stations that are in red, and these are individual snow observing sites in the mountains throughout the west, are places where the current snowpack water equivalent is under 50% of average, under 50%. And if I go over to the basin conditions, when you sort of look at this from the perspective of the entire basin, and I want to move over to a slightly more scientifically justified color bar, here we go. You can see that every single basin, and now there are no exceptions in any sub-basin anywhere in the Western U.S., every single basin is now below average, but there's a gradient in the below averageness of basins, if you will. If you look at this map, you can see that the Northern Rockies are doing relatively less poorly, although now even here snowpack is mostly in the 75 to 85% of average territory, which is still noticeably below average. Again, here we already have our climate warmed average baked into this, in the sense that this is again relative to the last 30 years of climate data, which already incorporates a 10 to 15% loss in snowpack due to historical warming. So if you were comparing this to peak early to mid 20th century snowpack values, you actually have to subtract in many locations 10 or 15% from these values. So we're kind of cheating with that baseline already, and yet even then it looks terrible. But again, it varies a lot from place to place. The Northern Rockies doing okay. The Southern Sierra, well, it's not doing as well as it was previously, but it's relatively less bad. But you go northward throughout the Sierra Nevada mountain chain. We go from about 74% of average in the Tulare Basin, the southernmost portion of the Sierra that drains into the Central Valley. The San Joaquin Basin is already down at pretty abysmal levels, 61% of average snowpack. That's the San Joaquin River, drains into the Delta. Sacramento Basin already down to 41% of average. Of course, that also drains into the Delta from the north, and we get up into the Shasta Mountains and north into far northern California, into the northwestern mountains of California and Oregon. There is almost no snow. Snowpack of like 20 to 30% of average. Really, really low. Getting even lower than that as we go into the northern Great Basin and up into Oregon with 15 to 25% of average. The other real point here is that there's a swath where I'm most concerned about this low snowpack, and it's essentially in this swath here. This is where I'm especially concerned about the extremely low snowpack. So why am I less concerned up in Washington state? Well, the snowpack is still really low up there, but they've had a reasonably wet winter, and it looks like they're about to get a pretty warm atmospheric river next week as the rest of the West gets a heat wave. So they've got the water, they don't have the snow. It's been very warm, but at least there's a significant amount of water. The Northern Rockies, this is still probably going to be a problem to a certain extent, but there is at least decent snowpack, even though it is still well below average. It has at least persisted and will persist into mid-March. Also, the upcoming heat wave, although it will affect this region, will be less intense up here than it will be down here. California is doing okay because, as I mentioned, the winter wasn't super dry. In fact, it was still wetter than average in the Southern Sierra, and in the Southern Sierra, the snowpack is doing okay. But there is much greater concern up in far northern California, where it's fair to say a lot of California's water supply is, and the mountains are lower, so this is a more consequential low snowpack event from an ecological and potential wildfire risk perspective. But the real problems, I think, are going to emerge in Oregon and far northern California later this year. This is a major early forest fire signal, and I am being specific about forest fires because the lower elevation grass and brush fires in most cases aren't going to respond as much to a snow drought, because in those locations there isn't usually a tremendous snowpack on the ground come spring and early summer anyway. But in the mountains there is, and this marks a pretty large departure anomaly. Even though soil moisture is near to above average, that's quickly going to go away because there isn't really much snowpack to replenish it later this spring into the summer. So even though soil moisture is above average right now, this critically low, even record low snowpack in this region from Northern California into Oregon is going to pose problems from a true forest fire, higher elevation forest fire perspective later this season unless something changes dramatically. The same thing is true across the Great Basin, into the Four Corners region, and into the southern and even parts of the Central Rockies. This is a part of the country where we're probably going to see a very early and quite serious start to the fire season. I would expect quite a serious start, especially in the Four Corners region, and then Utah and Colorado may have some real problems as we get into the summer months. It's still going to take a little bit longer because even with a record low snowpack, there is still snow on the ground at the highest elevations, although that's going to start to change because this part of the country will also experience record warmth in the coming days. This general region, for those asking about where I'm so concerned about wildfire this season, this is going to be the peak in the swath from Oregon southeastward across the Great Basin. the southern Rockies Four Corners region especially. Doesn't mean we won't also see problems later this summer up here, but the snowpack is going to be a little bit less predictive of it because it's not quite as extreme. Doesn't mean we couldn't see Sierra Nevada fires popping up earlier and more strongly than usual throughout the mountain chain, especially with the relatively poor end of the season in the cards, but it also is mitigated somewhat by the high soil moisture and the relatively high seasonal precipitation down here. Now, Southern California, of course, never has a great deal of snowpack. It snows in the mountains, but it's not a hugely significant part of the hydrology there. The wildfire situation coming up, well, we're probably going to start to see some fire activity during this upcoming record-shattering heat wave, but we're not near peak seasonal dryness at this point, so it's unlikely we'll see widespread or really extremely elevated fire weather, not because the weather won't be extreme, which it could be pretty extreme actually, but because the vegetation moisture is not at critically dry, seasonally dry levels following an unusually wet winter. Even though it's been warm and dry recently, don't forget that that context matters. But here's the problem. That's going to protect coastal Southern California for the next month or so. But what happens beyond then is going to be another question, because we do have the challenge of having gone through yet another wet to dry weather or hydroclimate whiplash episode in coastal Southern California, because we had, again, a literally record wet start to the water year from October through December and ended the total season wetter than average, just based on what already fell. And now we have an extraordinarily long dry spell with probably the warmest March conditions we've ever seen in coastal Southern California, with no rain whatsoever on the horizon. So do we go from another really wet period with abundant growth of herbaceous vegetation, grass, and brush in coastal Southern California and enter another active fire period thereafter later this summer? That is possible. The one difference between when this happened in the transition from the very wet 2024 to the very dry late fall 2024, early 2025 winter, which is when we had the catastrophic LA fires, is that the temporal sequencing there was wet to dry immediately leading up to strong dry offshore wind season. We can get some offshore winds in spring, but it's asymmetric because we generally do not reach peak seasonal dryness in spring. So fortunately, during the spring Santa Ana winds, usually, although we can see fires, they're usually somewhat less risky fires because vegetation has not had a long dry summer to bake and to dry and to cure. So that is a little bit asymmetric. So then the question is, okay, well, this winter we're ending on a wet note with abundant grass and brush growth. We probably are going to have a fairly dry and warm spring. What does the summer then bring before the fall and winter offshore wind season to come? That's a question mark right now, and it actually might not be what you expect. With an upcoming potential for a very strong El Nino event, there might actually be an unusually high potential for a saved by the bell type outcome sometime this summer or fall in the form of tropical remnants bringing aseasonal precipitation when some decaying tropical storm or hurricane recurves somewhere toward the southwest and moves inland, kind of like Tropical Storm Hillary. Obviously, there's nothing on the horizon right now. This would be months away, but I'm speculating and spitballing a bit here. So that means that the coastal Southern California fire question this summer and fall, big open question mark. But less of an open question mark, I think, is essentially this region. And it looks pretty concerning for a wide swath of the West. And I do think, in general, this may be a summer more characterized by true forest fire risk rather than grass and brush fire risk. This is the kind of seasonal, higher elevation snow drought signature where we actually do tend to see more of the West's higher elevation coniferous forests, in particular, see much elevated increases in wildfire activity. And I will also point out, Colorado River Basin, which I'm outlining very crudely here, is in trouble. This is bad news. Can we quantify bad news better? Well, here's a time series plot of the upper Colorado Basin snowpack. Here is that recovery we just, quote-unquote recovery. We bounced back up to the literal bottom of the barrel in the upper Colorado Basin with snow in recent days, literally just keeping pace with essentially the worst year on record. But once again, in the last couple of days, as I expected, unfortunately, we've now started to drop below the all-time low trend line once again, with current conditions in the 0th percentile. 0th percentile, the literal lowest value in the observed time series. And unfortunately, given the record-breaking temperatures and lack of snow to come, if you look at the previous record bad year for snowpack in the upper Colorado River Basin, you can kind of see this precipitous decline. I would expect a similar trajectory, but starting from earlier and from a worse point. This is not going to be pretty in the Colorado Basin. We're going to get to really terrible levels of snowpack probably sooner rather than later. And even though the upper basin is critically important for the volume of water, if we look at the lower basin, if you're looking for any relief, you're not going to find it. We actually were doing less anomalously bad after some snow earlier, but again, we've once again reached, we're sort of tied with the all-time record low for this time of year. And again, some of the parts of this basin are going to see temperatures in the 90s Fahrenheit over the next week or two. So I think we could see a record early loss of snowpack in the lower Colorado Basin. It may be essentially gone by April 1st. So right around by here, it may essentially be gone. And that would be by far the earliest that that's ever occurred. And that's kind of scary. If we go to California, again, this is amalgamating all of California's basins. So it's adding together the much less dire situation in the Southern Sierra with the quite dire situation up in the Shasta Mountains. But obviously, we're not at record lows, but we're pretty low, and it doesn't look so great. If we drill down to some other basins here, some smaller basins within California, for example, if I look at the Sacramento Basin, which is a hydrologically critical basin, you can kind of see that it's not the worst it's been, but it's in pretty bad shape, and we've actually had a pretty steady decrease in snowpack since late February, so that's also unusual for this time of year. And if we look at another basin, for example, let's look for somewhere way up in the north. Let's look at the Truckee River somewhere, and we can see that, well, this is maybe not the best example because again, well below average, which would be green, but not record low. I'm just trying to find a basin. I don't know which basins are actually actively. Well, we could look north coast, which is not here. Anyway, I don't want to belabor the point here. You get the idea. It's not in great shape. I have to close a few windows here so I don't crash anything. And one last basin plot I want to show is just the Pacific Northwest. And in particular, I want to look at, because this is conflating Washington with Oregon, let's look at Oregon specifically. And let's state of Oregon. Let's see if we can get that plot. Yeah, so again, just above scraping the bottom of the barrel here. So essentially near record low snowpack in Oregon, and I would expect it to essentially follow this record low trajectory with complete loss of snowpack by around May, whereas usually that wouldn't happen until nearly July, the second half of June. Okay, so closing a few of these to move on. We do also have, as I mentioned, a major marine heat wave. I keep pointing this out. You can start to see, by the way, let me get a different drawing tool if I need a pink, so all the bright colors here. The developing El Nino event in the eastern tropical Pacific Ocean, that's visible here. We have El Nino costero conditions already in effect, so the coastal El Nino declared by Peruvian meteorological officials, and you can see why. It's already very warm. This is shaping up to be an east-based El Nino event, so I'll talk more about that later. But the part I'm talking about right now is this really warm water all the way along the Pacific coast from Vancouver Island south to central Mexico. See all these oranges and these reds all the way up the California coast. This is it's now expected to persist through the spring, into the summer, and probably into the fall. So anomalous coastal warmth is not likely to go anywhere, and this is facilitating the extreme heat we're seeing, because unlike acting as a natural air conditioner, the unusually warm near coastal areas are actually trying to amplify the magnitude of some of the heat we're seeing right now rather than mitigate it. Okay, so what are we headed for? Well, here's the literal big picture. Here is a map of the 500 millibar geopotential height anomaly map, essentially averaged over several days. And actually, let me get rid of the diurnal averaging. Let's just look at day by day. This is a measure of the thickness of the lower half of the atmosphere. The brighter oranges and red colors, the thicker the atmosphere, meaning the warmer the atmosphere, the darker the blues, meaning the shallower or the cooler the atmosphere on average. And what you're going to see is over California and Southwest, as we step forward in time, this is going into Friday, a large ridge develops over, right over, essentially centered over California and the Southwest. And then this starts to this sort of amplify in place. The Pacific Northwest, California, the West in general, we're now 7 or 8 days out, so this is next Tuesday, and amplifies even further, strengthening to really extraordinary magnitude by next Wednesday and Thursday, just anchoring itself over the Southern Rockies, the Great Basin, and not really going anywhere, slowly de-amplifying in place, but remaining a fairly substantial ridge before maybe partially, although conditionally breaking down toward the end of March. Even that's a little bit speculative at this point. But again, this is I'm going to zoom in a little bit on this map because it's kind of a striking image. And if we go to the normalized anomalies here, we can literally see just how extreme this is. This plot is in units now of standard deviations, where 2 standard deviations is a pretty darn big deal, and we see that a lot of the West is more than 2 standard deviations from typical mid-March values of this lower atmospheric quantity. In fact, this would be a fairly respectable ridge of high pressure for midsummer. And again, we're not in summer, and I've had some folks reach out to me in recent days and say, well, it's not that unusual for it to be 100 degrees in the deserts or 110 degrees near Palm Springs or something. It gets like that every year, which is true if this were July. But it's not July, it's March. And that's what I find so silly about some of these arguments. Like, well, this is nowhere near the hottest temperature we've ever seen in Phoenix. It's only going to be 98 degrees. Well, sure. It's been a lot hotter than 98 degrees if we look at the all-time July temperature records for the same place. But it's all relative. The context matters. And we're literally in the first half of March. We're not even well into spring. Winter has just barely ended. In fact, meteorological winter is depending on which definition, astronomical or meteorological, we're still in winter. We haven't reached the point where we shouldn't expect to see winter-like conditions, because meteorological winter often lags astronomical winter in the sense that we tend to see cooler temperatures linger past February than we do cooler temperatures arriving before December. So it's asymmetric. Anyway, just as a broader aside, this notion that somehow the fact that March temperatures are going to be record-shattering in some people's mind is unremarkable, because those very same places see much hotter temperatures in a typical July. Well, sure, that is true and also completely irrelevant, because, again, that context matters. Would you say that it would be unusual to see a 0 degree Fahrenheit temperature in Chicago in January? Probably not. Chicago can get very cold in winter, sub-zero. Everybody who's lived there is aware of this, and I think most people in the world know that places like Chicago and Minneapolis get really, really cold in winter. So to see 0 degrees, minus 10 degrees Fahrenheit in January would not really be that unusual. Would it be very unusual to see a 0 degree Fahrenheit reading in August in Chicago? You bet it would be. It's never happened. It's never come anywhere close to that, because it is just not the time of year when that tends to occur in this part of the world for very well understood geophysical reasons. Likewise, if you decided, for example, to say that it was not that unusual to see 110 degree temperature because it gets that hot every summer in Phoenix, but applied it to Seattle, that logic also doesn't work, because of course space and time are both part of that critically important context. If you had a temperature of 110 degrees in Seattle at any time of year, it would be a massively disruptive and deadly heat wave. 110 degrees in Phoenix in July, as people have pointed out, is of course quite within the norm and expectation of what you would expect to see in that place at that time of year. So, yes, when we talk about record heat, we are talking about record-breaking high temperatures relative to a particular location at a particular time. So it is all relative, and it's apples to apples, to use that favorite expression of mine. We are making a like-for-like comparison. We're not comparing temperatures in Los Angeles in March to temperatures in Los Angeles in July. That wouldn't make sense. We're also not comparing temperatures in Los Angeles to temperatures in Chicago, because that also wouldn't make sense. It's temperatures for this time of year in this part of the world. And in that context, what we're about to experience is truly extraordinary. How extraordinary, you might ask? Well, when we look at some of this, the temperature anomaly map moving forward in time, this is a prediction from the European Model Ensemble, one of the better ensembles in the world. You start to see some of these hot pink shades show up. And again, these are in units of Celsius on tropicaltidbits.com. So you multiply to get to Fahrenheit. And what we're really talking about here, when in some of these bright pink zones, and again, we start to see these pop up all throughout California, all the way up toward Lake Shasta, Redding, by next week. We're talking about temperatures that are 10 to 15 degrees Celsius above average. So we're talking 25 to 30 degrees in some cases Fahrenheit above March averages. That is going to break a whole heck of a lot of records, and not just daily records, not even just March monthly records, but in some cases will break records for the earliest 100 degree or 90 degree or 80 degree temperatures ever observed in many parts of the West by weeks, not days. So this is really just going to obliterate some early season temperature records throughout the West. And what's remarkable is this isn't just going to affect one or two cities, but it's going to affect essentially all of California, all of Nevada, all of Utah, all of Arizona, and then much of Oregon, Idaho, New Mexico, Colorado, Wyoming, and adjacent states at various points during this event as well. As you can see, we get into next week, and actually I hadn't even advanced it this far. Now we go past hot pink into this burnt crimson purple. I don't even know what to call it exactly. We're getting up to and this is affecting places like Reno, or the foothills of the Sierra Nevada, or the Flagstaff, Arizona, Sedona, Arizona, the higher mountain regions, the valleys of Colorado. These are just ludicrous numbers for March. What are the numbers actually? Well, if we look at what some of the high temperatures are actually going to be, again, this kind of looks like a summer temperature map at the surface. And if I zoom in a little bit, I'm going to do this on a different model page, what we're talking about, so here are temperatures, here is tomorrow's temperatures already getting up, this is well above average, mid-70s, we've already been seeing that in the Central Valley, 70s to 80s in Southern California, so warm, but what we've already seen this winter, getting into the 80s in the deserts of the Southwest, but this is just tomorrow, this is the very beginning. Much hotter already on Thursday, and here we're already getting into the 90s. I mean, we're talking about mid-90s, 95 degrees near downtown LA on Thursday. This is already essentially the hottest it's ever been this early in the year in LA, and this is already happening on Friday. So mid-90s in LA on Friday. We're starting to heat up Northern California. We're starting to get toward 80 degrees. We're near 100 degrees in some of the hottest desert regions. But then we actually see some even hotter values. It's possible that some locations in the southeastern deserts of California will see the earliest 110 degree reading on record at some point during this heat wave. The early part of the heat wave, by the way, will not be quite as intense across Northern California, although still well above average. The real extreme temperatures might not actually come till next week in some locations. So we see further amplification in the desert southwest. We see temperatures that day and night are warmer than average even throughout the Sierra Nevada. And now we start seeing some 80 degree temperatures, 85 degree temperatures near Sacramento as we go into Sunday and into Monday. Now we see widespread 80s in the Central Valley, even getting close to 90 degrees. 90s return to Southern California, Phoenix in the 90s. We see, all of Nevada essentially in the 60s, 70s, and 80s. Again, it's March. It's March. This is just wild. Next week could see 90 plus degrees in some parts of the Central Valley and widespread 100-degree temperatures in the deserts. You can just see this heat wave just continues to escalate as we step through time. And as we get into later next week, we actually see mid to upper 80s in places like Sacramento, potentially 70s and 80s in the Bay Area. Just a long stretch of 90 plus degree weather in the LA area. Again, we just see temperatures rising further and further close to the 110 degree point in the southeastern deserts of California. We see mid to upper 80s just day after day in the Central Valley of California. Now we're getting up into the hundreds in Phoenix as the heat wave intensifies. Now it's up into the 70s, even up into the Sierra Nevada, up in the mountains. Keep in mind what that's going to do to the snowpack. And again, we're talking about temperatures near 90 degrees in the northern Sacramento Valley as we get into later in March. There is the potential for, again, a pattern change later in the month. I'm not going to talk too much about that because that's speculative, but these, again, are just absolutely ridiculous numbers. I know I keep repeating that same language, but I just want to point out, for example, Denver, the mile-high city, 90 degrees. 90 degrees in late March. But between then and now, mostly in the 70s and 80s in Denver. 85 degrees. I mean, we're talking potentially a week to 2 weeks of 80 plus degree temperatures at 6,000 feet in the Rocky Mountains in March, with some places getting up to 90 degrees. It's genuinely hard to fathom for me personally. And to that end, let's see if this product has been trying to load for 45 minutes. Okay. Let's see if we can actually, I know this is a lot of clicking, but let's just see what we get. I think this is being used by so many people I can't access it. So I'm going to skip it, actually. I'm going to go to this instead. Here's a product from the, this is not let's see if we can update this as well. Okay. So here, lots of record high temperatures, by the way, today in the eastern U.S. And tomorrow in the eastern U.S. as well. Nothing in the west. But look at what happens as we go through the week. So here's Thursday. And every number on this map, by the way, is an official National Weather Service predicted temperature that reaches or exceeds a high temperature in that location. So already we're seeing some 80s in the Central Valley, the Bay Area, that are going to be record breaking. And in coastal Southern California, for example, here are the predicted temperatures for Thursday. Again, 97 degrees. 97 degrees in Long Beach on March 12th. 95 degrees Riverside. 97 degrees downtown LA. Even 89 degrees at LA Airport. And remember, LA Airport is literally on the beach. 96 degrees Burbank, San Fernando Valley, even into Oxnard, Camarillo, 92 degrees. I mean, these are just mind-boggling numbers to me. And then these numbers just start to get more and more wild as we go throughout the week. Reno, Nevada, 78 degrees on Friday. We see even more 90s in LA. In fact, it might even be even hotter. 98 degrees in Long Beach. 99 degrees in Los Angeles, meaning there is a chance that downtown LA could experience a 100-degree temperature in March, which it has never done before. That is a distinct possibility that at least some part of the LA basin will be above 100 and thereby break its monthly temperature record. We go into Saturday, and let me zoom out a little bit. We go into Saturday, and the records start to spread. So now we have, again, still some records in Southern California. We have Phoenix at 95, Las Vegas at 88. We start to see records into Texas and New Mexico and Colorado. And then we get into Sunday, we start to see records expand even further. So now we have Redding up in the upper 80s. We have Sacramento, 84. Again, this is remarkable warmth. We have San Jose getting into the mid-80s. And then on Monday, we actually have a further resurgence in records with temperatures getting up closer to 90s again in the Central Valley. And again, high 90s in the LA basin, hundreds in the deserts, and this doesn't even go far out enough. If you could extend this another week out, you'd start to see things popping up all throughout the West. So again, these numbers are mind-boggling. All right, so I'm going to go back to sharing my full screen so I can take just a few questions here. All right, so this is your opportunity to submit some questions if you haven't already. I'll once again take a moment just to remind folks that if you haven't already done so, you should subscribe to the channel to be notified when I have these conversations. Okay, so I'm going to answer some of the questions and look for others that might be coming in. Just bear with me as I read. As people point out, it's 70 degrees in New York City already today, so it's getting warm. There's some record heat in different parts of the country this week, but it's going to shift around. Dr. Mediterranean comments or asks or pleads, rain through summer, please. Well, there is probably a higher than average chance of at least some possible late summer, fall tropical remnant precipitation events, at least in Southern California and the Southwest. So by no means a guarantee. Always a bit of an outlier when it occurs, but the odds probably will be a bit higher this year than usual, thanks to El Nino and the marine heat wave. So I'll talk more about that later, but for now, let's get through March. Comment that the feedback is that we're enjoying the drippy weather here in PDX, so Portland, Oregon, while it lasts. And yes, in fact, you might get some decent precipitation to come, and even more so up in Seattle. In fact, you might even have some flooding to deal with in the coming days, because on the northern edge of this, well, ridiculous ridge, let's call it that. Let's call a spade. There's actually going to be a prolonged, warm, very warm subtropical atmospheric river. Does that sound familiar? It will not be contributing to snowpack, but will probably be snow eating. So it will contribute water, but it will be, once again, rain on whatever snowpack remains. So it might finish off the snowpack and across a decent portion of Oregon and Washington, but it will add some water, and it will prevent extreme March heat from making it quite that far north. So up there, it'll be wet and warm, not record warm. South of that, though, we're just going to get this ridge. And I will point out, by the way, and this was actually somewhat akin to what happened during the record-breaking, record-shattering June 2021 heat dome event across the Pacific Northwest, is that an upstream warm atmospheric river dumped a bunch of energy into the atmosphere in the form of latent heating in the area upstream, so upwind of the big ridge. And so even though there was heavy precipitation and lots of extra moisture in the atmospheric river upwind, that actually contributed to amplifying the magnitude of the dry heat in the middle of the heat dome. I haven't done a full process-based analysis, but I suspect that there's at least an element of that might be at play here, where latent heating from the prolonged and very moist atmospheric river plume, which will be producing a significant amount of condensation and precipitation, as they tend to do, will be contributing some latent heating to the upstream air mass, which might help contribute to increased what's known as moist static energy, or MSE, in the persistent ridge feature over California and the Southwest, thereby potentially amplifying both the magnitude of the ridge through diabatic ridge building, not diabetic, but diabatic, as opposed to adiabatic processes. And in a very counterintuitive way, contribute to the extreme dry heat across the Southwest precisely by virtue of how wet it is in the adjacent region. There is an atmospheric mechanism for that to occur, and this is kind of the setup where we've seen this happen before. If anybody in the weather, even weather geekier than I am side of things, has any data to support that, I'd be curious if you could send it along. But I'm pretty sure this is a process that's operating, or will be operating at least later in this event during the second phase, once the ridge has established itself and once that atmospheric river is dumping some water on Seattle, but not dumping any water on California and the Southwest. Question from Matthew: why do the models keep floundering with these heat waves? They consistently underestimate the strength and duration of the heat. Are they trained on climate that no longer exists? This used to be an easier question to answer because it used to be that climate model and weather models were not trained at all on weather or climate. They were purely predictive models, very unlike all other types of predictive models that were based purely on the physics and chemistry and the equations thereof. And so, therefore, they weren't trained statistically to behave like anything in particular. All the weather features, all the storms or heat waves that were simulated by them were purely emergent properties of the physics and chemistry as encoded in these large systems of numerous partial differential equations solved on supercomputers. That is still true, by the way, for the majority of the weather models that are used today. But increasingly, with the advent of AI weather models, that's no longer quite the case. And we have essentially artificial intelligenced our way into that exact problem that I used to say didn't exist, because now these AI weather models are trained statistically in the way that people used to think physically based weather models actually were, in the sense that they learn, they're extraordinarily advanced pattern matching machines, which doesn't necessarily diminish them. It just means that it's a different process of developing a prediction. And in these new AI weather models, we do in fact see, and I'm always 6 or 12 months behind the very latest science, but the 6 months ago recent science suggests that in fact there is a problem with many or even most or all of the AI weather models when it comes to the most extreme tails of the distribution. So they're very good at essentially being historical weather emulators. They're very good at re-representing weather conditions to the extent that we've observed them before historically, and generalizing to a limited degree beyond that. But what they don't appear to be good at doing is looking or extrapolating well beyond the observed horizon. So when there is a truly unprecedented extreme weather event, that is in fact where a lot of these AI, these new hype-driven, and again, the hype is justified to an extent. These much discussed AI weather models, where that actually can now be a point of failure, where there is a degree of training on historical data that is extant, and in future data, which is not extant, we haven't observed the future yet, unless anybody has invented a time travel machine that I'm not aware of. That does cause a problem with generalizability. We see this with every kind of AI model that has existed so far, to my understanding, whether it's an LLM or an image processor or whatever, where you can potentially at least build a model that is very good at assimilating all known data and interpolating and drawing inferences that are drawable on the basis of what is already known in the training set of data, but in many cases not so good at, if you will, reading between the lines or extrapolating into an unseen portion of the data. And in a warming climate, virtually the entire future is going to be an unseen future that is not in the historical training set. So ironically, this is a problem, or my answer has changed with AI models. With traditional physics-based models, which are still the ones I was using today, by the way, this is not a problem. And in fact, there is no evidence of a systematic bias against extreme heat waves, except that whenever you're making a prediction for many days in the future, what you really should be doing is using the ensemble, meaning using all the available different iterations of model predictions, using slightly different initial conditions, because we don't know with absolute certainty what the initial state of the atmosphere is, which can lead to cascading uncertainties, and so you want to account for them. So you use all of those different tiny perturbations of potential initial conditions, you feed them all into exactly the same computational model, and they all produce different outcomes, most of which are probably similar, but some of them actually diverge pretty substantially. You want to look at that full distribution of outcomes when you're looking more than a few days in the future, because that initial condition uncertainty propagates to a great degree. It becomes very important in driving that uncertainty beyond about 3 to 5 to 7 days in the future. So we use the ensemble for that. The reason why, on average, the ensemble is always going to produce a weaker signal than the most extreme individual member is it is just that. It is an average across a range of possible outcomes. It's very likely, for example, in this case, that one or more of the individual ensemble members from among these differently perturbed initial conditions probably correctly predicted whatever this heat wave is going to do. So it might have been one of the more extreme members. And as we've gotten closer to the event in question, the ensemble average has increasingly converged. It's moved upward as which of those members is most likely becomes clearer as we get closer to the event, because there's less uncertainty, A, in initial conditions. Well, what I should say is the uncertainty in initial conditions as we get closer to the event becomes less and less important in a traditional physics-based model, and to a lesser extent in most of the AA models as they exist right now. So it is an interesting question. Will we eventually build those AA models so that they behave similarly in terms of what they do under novel and unprecedented conditions? I hope so, and there's some evidence of progress toward that, but that is sort of at the cutting edge of artificial intelligence and of meteorology and atmospheric science right now, and it's not clear that's a problem that has been solved. In fact, I would argue that it's pretty clear that it's not been solved. The big question right now is it solvable? Because if it is, using the existing kind of AI weather model framework, generalizability into unseen futures, then this becomes an even more powerful tool. If it's not, then it puts a pretty severe limit on how useful these AI weather models are going to be in a non-stationary warming climate, and in particular for the most extreme iterations of events, particularly when there's a risk of a historically unprecedented event, which you might say is exactly when we would want to have those predictions to be correct, because that's when it's most important. So will we or won't we? I don't know. We will see. Interesting tangent, hopefully, for those who have remained on the line as we hit the hour. I'll give a few bonus minutes just to get through some of the remaining questions here. Violet mentions that there were quite strong Santa Ana winds down near San Diego over the weekend with a couple of local fires. That's not surprising. I would expect there to be additional pickup in fire activity as what are known as fine fuels dry out. So the seasonal grasses in Southern California during this heat wave, they're probably going to start to cure, especially away from the low, the basins, the ponds, especially on these south-facing slopes or the sun-facing slopes. We're going to see grass cure and start to dry out and behave like the 1 to 10 hour fuels that they are. So yes, we are going to see an increase in fire activity. If it gets windy, we don't know yet. There could be some offshore wind events with 90 plus degree temperatures and low humidity. That is fire weather, although again, vegetation is not, I repeat, not at critically dry levels. So we may see elevated fire risk. We will probably not see extreme fire risk in California. Now, in the Front Range in the Rocky Mountains, that's a different story. We are expecting extremely critical fire risk once again in the days to come. But I do think we'll see an uptick in fire activity in coastal Southern California. I will point out, once again, this does not mean that every fire is a bad fire. It does not mean that fire risk will be extreme yet. And in fact, there will likely be in Central and Northern California some good opportunities for some prescribed burning as things heat up in areas that have been relatively wet, in particular places that saw a decent amount of snow or rain earlier this season, because the ventilation index may be reasonably good. You might be able to vent that heat away on some of the days where there's a little bit of a convection column that can get going on some of those prescribed burns. So you probably will see some smoke plumes throughout the West during this period, and ideally many of them will be risk-reducing prescribed burns, but there is going to be an increasing risk in some parts of the West of unwanted wildfires, even though I don't think in the short run the risk will be extreme in Southern California, though it will probably be elevated at times. The spring-like fire conditions emerging. The bigger question for me is what happens later in the season, because we are potentially set up for much of the Rockies, the Pacific Northwest, and the Sierra Nevada mountains, the higher elevation forests, to have a very different and much more active fire season than we've seen the last few years. And in coastal Southern California, where we go from spring into summer into fall will depend on whether we get saved by the bell by a tropical storm Hillary 2023-like event again or not. I think that was 2023. I'm losing track of the years at this point, so forgive me. Matthew mentions it looks like the heat might subside after the 22nd and the last week of March, early April, at least in Northern California. Could see some unsettled weather, some cutoff lows in April. That's absolutely possible, if not plausible, because that is what you would typically expect to see in March and April. The real issue is that it means we've sort of lost these last few weeks of core snow accumulation. That's what we're really losing. And we're losing it both because of low precipitation and extraordinarily hot temperatures for March. So it isn't just dry and cool or warm and wet, but it is unfortunately going to be both dry and extremely warm. And the real issue is that even if we get that unsettled cooler weather late March, early April, it's certainly better than not getting it, but it will be a real challenge to make up at that point for the accumulated snow deficits in particular, and the accumulated evaporative deficits as well, as this genuinely extreme and prolonged heat wave persists. And just to be clear, there's those ensembles I was talking about. They're not clear on whether we actually get rid of this heat wave at the end of March. Some ensemble members say yes, we go to cooler and more unsettled, but some other ones say nope, you're just going to continue to get more 90-degree temperatures and dry weather in March for much of the West. That ridge might end up being more resilient than we think right now, and that is a known issue in models where sometimes they tend to dislodge persistent ridges a little too early, particularly when steering flow is weaker. And as we go from March into April, we know the Pacific Jet, the dislodging actor for some of these persistent ridges, just seasonally starts to weaken, so it probably won't be able to exert as much of an influence then. The question this year seems to be an increasing trend. Low snow, early melt, yet a lot of winter precipitation falling as rain versus snow that can be stored. How do water managers adjust reservoir storage and releases? Well, this is a great question, and it's something that's very central to some of my own research and collaboration with folks in the water world. The real answer is that it's complicated. And it does severely complicate water management in the West because we built most of our water infrastructure under the predicated assumption that we would have not only rain in winter running off into reservoirs, but also snow melting into reservoirs progressively and slowly and gradually from spring into summer when we need it most. What that means right now in Northern California, the Department of Water Resources and the U.S. Bureau of Reclamation have both emphasized that they have to essentially let all the water that's flowing through into the reservoirs right now go. They cannot store the snowmelt that is currently occurring or will occur. Why is that? Well, California's large dams, this is true of other dams and a lot of other parts of the West as well, serve not only as water storage, but are actually primary flood control structures. So you must maintain flood safety margins, especially during the wet season. And again, I remind folks that we are only in the first half of March. California can see major storms throughout March and even sometimes into April that could cause flood risk. So water managers, dam operators are cognizant of that potential for a major storm that, if one of those outlying ensemble members, for example, ends up being right, late March, early April, there could be a major atmospheric river or something in California that could cause flood risk. So they have to hedge against that risk. They can't keep reservoirs full to the brim. They need to maintain that flood safety pool, that margin that allows you to have a large inflow of water without overtopping the reservoir, which is very dangerous. You do not want that to happen. And dam operators rightfully are going to try their damnedest to make sure that it doesn't. But one of the ways they do that during the wet season, which again we are still in despite what the weather forecast shows, is maintain that flood pool. Now, one thing that is being done is known as forecast-informed reservoir operations. It's a bit of a tongue twister. FIRO, F-I-R-O is the acronym. And it's essentially saying they're keeping more water than they would have 20 years ago in some of California's reservoirs because, in fact, they're saying, well, yes, it's the wet season, but we do actually have functional weather forecasts, and we know that there isn't going to be a big storm in the next week in our watershed, and so we can keep an eye on things, but for now, we're going to keep a little more water there than we would have 20 years ago because we think we can do so safely because of that forecast. That's a really good use of technology. It's actually a use of technology so that we use less technology, which is a really clever way to think about it, but it's a way to save water by doing nothing and by leveraging good weather forecasts to do so. But even here, not all dams are authorized to use forecast informed operations, although the list is expanding. This is something that the Army Corps and the U.S. Bureau of Reclamation have been slowly adopting over time, along with folks in the state of California. There's also a limit to how much you can do, because even with a good forecast, not every forecast is guaranteed to be 100% correct, and the stakes are high, but also we really only have reliable forecasts out 7 or 10 days for something like the tail risk of a major flood event. So we can't say, well, it looks dry for 2 or 3 weeks, so we can fill the reservoirs up. We still have to say, well, we can give ourselves an extra 3 or 5 days of margin, but we can't really be too aggressive going out further than that, because here, it's not like me saying what I think is probably going to happen. If you're trying to avoid a catastrophic incident on a dam, you got to actually look at the low probability outcomes, the low probability odds, the 1 or 2% risk that there is a big storm, even if there's a 95, 98% chance that there isn't one. So that's why there are limits as to how effective that can be, while it still is much better than the historical status quo. But the real answer is that yes, this is a big problem, and this is why California's water situation is not what it might appear. We have high rainfall levels, we have reservoir levels that are above average, and we have a snowpack that is not going to contribute very much water, if at all, to that combined snowpack reservoir storage level by the end of spring. So there's snowmelt now, but all that snowmelt by virtue of our flood control system has to just flow through. And there are ecological benefits to the water in the river, so it's not wasted in the sense that some people sometimes claim it is. So water in the river is having ecological benefits, of course. And some of it is probably being captured for off-stream storage, so people may be authorized to take more than their usual allocation in some locations, farmers or water districts in the Central Valley, because water managers know that they're releasing more water than they would like to be at this point, and that there might be less water released later. So take what you can now and store it where you can today. And so there are some adjunctive sort of interventions there. But again, there's limits. And our water system is predicated on a climate that no longer exists. And the main evidence for that statement is what is happening with the snowpack, because that is the key part that has changed pretty dramatically, especially in our warmer and drier years, which this year is right there at the top of that list. There's a question from Charlotte Morrison. Daniel, can we hope for any coastal fog relief in the Santa Cruz Monterey area? Probably not in the near future. It's going to be a dry, warm period. So it's going to be more like a fall-like heat wave in March. Not like a typical summer heat wave by any means. Could there be more fog later in the spring, closer to peak fog season, May, June, maybe, in June gloom? That seems more plausible, although again, I do not think this summer is going to look like the last few summers. I do not think the coast is going to be nearly as foggy and socked in as it has been the last few years. Inland areas have baked, but the coast the last few years, especially May, June, July, have been on the much cooler side because of fog. This year looks very different. The nearshore ocean is very, very warm and is expected to stay that way. There might still be some marine layer, but it will be less persistent. It just won't be as cold. The marine layer itself will be several degrees warmer, as much as 5 or 6 degrees warmer. So instead of fog at 55, you have fog potentially in the low 60s, which is getting to the point where you actually start to feel a bit muggy. In coastal Southern California, you might see fog closer to 70 degrees even this summer at times. So that's the kind of year we're probably headed for. A bunch of new comments just came in. So let me see. Some of the journalists are submitting their comments now. Getting it in under the buzzer, I guess. Okay. Let's see here. Michael Guerrero mentions that the earliest 90-degree temperature in Sacramento's history was March 26th. It is believed. I don't actually know the statistic, but that sounds about right to me. So, again, it is possible we'll see the earliest 90-degree temperature in Sacramento history. That's certainly possible. We will see how hot it gets. It's certainly going to be in the mid to upper 80s. It might get up to that level. Ben asks why the map shows dark red just about everywhere, but then you look in the weather in San Francisco, it's in the low 70s, mid 70s at most. I actually do think it will get warmer than that in San Francisco. These coarse resolution weather models cannot always resolve California's microclimates and coastal topography. That said, as is almost always the case, San Francisco is usually cooler than anywhere else in the Bay Area, except for maybe Half Moon Bay because of the proximity to the coldest upwelling part of the ocean. And even though it is not as cold as usual and the upwelling is weaker than usual, the ocean is still, in absolute terms, pretty chilly. So we're talking like temperatures that are close to 60 degrees instead of being in the low 50s in some cases. So, that's still cold water. It's just less cold, and it still is acting as a nearshore air conditioner. So, but again, in March, if you're on the beach in San Francisco in March and it's in the mid 70s, that is really darn warm. Let's just put it that way. So, in relative terms, that may well be a 20-degree plus departure from average for this time of year in that place. Again, as I started with, it's all relative. Talk about El Nino more subsequently. There's just too much going on at the moment, but it does look like it's going to shape spring and summer and probably winter conditions next year significantly. Brendan asks, at what point can we definitively say, hey, this is global warming? There's a direct link. Right now, I will say it right now. Clearly, this winter it would not have been as warm as it was. The snowpack in the west would not have been as low as it was without global warming. So we can say that confidently today. In fact, we could have said that confidently in the past as well. But it is very clear that there's a direct link between the warming climate and how warm, ridiculously warm, record warm, whatever you want to call it, it's been both in California and in the broader West, and how low the snowpack has been. Is it the only reason? No. There are other contributors as well. There's still natural weather and climate variability superimposed atop that global warming trend, but it is almost impossible that this winter would have been anywhere near as warm as it was were it not for that long-term warming trend, and it's unlikely that the snowpack across the west would have been anywhere near as low as it would have been. In fact, if anything, this is sort of a classically climate change tinged winter because the snowpack is extremely low across most of the west, not because precipitation was extremely low, which would have had a weaker link to climate change, but specifically because temperatures were record warm. That is the classic signature of a warming climate on mountain snowpack, which is to say the elevationally dependent and temperature dependent loss of that snow because it either fell as rain rather than snow because you're on the wrong side of the freezing line, or because it fell as wet snow to begin with and melted quickly amid anomalous warmth. That is exactly what we've seen this year. Question from Lisa Fisher. What about winds during this heat event? Asking for Boulder. Well, unfortunately, it looks like as soon as Thursday this week, we're back to 60 or 70 plus mile an hour wind gusts with extremely low humidity and extremely critical fire conditions. The public utility are already talking about, the utility Excel is already talking about shutting off electricity preemptively again to avoid wildfire ignitions. I believe that would be at least the third time this season they have done so in this part of the world, and it probably will not be the last, with even hotter, windier conditions. And I do use the word hot because it is going to be in the mid to upper 80s potentially along the Front Range by later next week. Just mind-boggling, really, truly, conditions. But then again, it's going to be that warm and across much of the West as well, from sea level to 6,000 or 7,000 feet. A question from Ezra Romero, KQED. This is an obvious question. Can we talk about the role of human-caused climate change in this heat wave and the winter overall? Well, I think I pretty well addressed that, but I'll just reemphasize it. We know that the West is warming. We know that the globe is warming. We know that they're warming for exactly the same reason, which is the accumulation of heat-trapping greenhouse gases in the atmosphere due to human activities. aka climate change. We know that the West has warmed several degrees Fahrenheit already prior to this decade, and has warmed even more quickly in the past decade in many places. And so we can attribute at least that much of the anomalous warmth to global warming. And again, there were some Western states that were about 3 to 5 degrees Fahrenheit above average winter temperatures for the whole winter, and were the record warmest, experienced their record warmest winter on record. So if we've warmed 2 to 4 degrees Fahrenheit, and the margin of anomaly here is 3 to 5 degrees at a seasonal scale, what does that tell us about the contribution? I'm being deliberately vague here because I don't have the exact numbers, because that does require a more formal study. But the clear link is between, we know that winters are getting warmer, we know that's linked to climate change. We know that average mountain snowpack is declining, that's linked to climate change. We know that the flow on the Colorado River and the runoff in the basin is declining due to climate change. All three of those things are the three main headlines we've seen this winter. All of them have direct links to climate change. I would also add that, again, some of the hydroclimate whiplash we've seen is also plausibly linked to climate change. Southern California saw its wettest start to any water year on record from October through December. That is something we expect to see more of in a warming climate. Washington State saw record-breaking rainfall and severe flooding earlier this winter. Again, that expanding atmospheric sponge with greater swings between wet and dry as the evaporative potential of warming air increases. The wetter wets potentially wetter, the driest dries definitively drier. Talked about that expanding atmospheric sponge in figurative terms over and over again, and we just keep living the practical implications of that increasingly literal analogy over and over again as well. All right, we're getting close to the end here. We'll see what came in the last few minutes. Ferg Morris mentions airborne LiDAR surveying is being done throughout California. This is a great tool for FIRO. That's the acronym for Forecast Informed Reservoir Operations I mentioned earlier, as it gives extremely accurate quantification of SWE, or snow water equivalent. That is great, and it is definitely going to be the more data, the more real-time, accurate, reliable data we can get to improve those forecast-informed operations, the better. We're going to need everything we can get as we see more winters like this one. And just to extend my response to the climate change question, by the way, winters like this one could very much be the norm in just a couple of decades. A winter as warm and as snowless as this one across the West will not be anomalous in just 10 or 20 years. They will in fact be close to average on our current trajectory. That is the sobering reality. Today's extraordinary is tomorrow's ordinary, and I think we're already living that. This winter would have been almost unthinkable 30 or 40 years ago, and now we're living it. This winter, 30 or 40 years from now, will be entirely unremarkable. Maybe even on the cooler, snowier side of things in some places. And I really think it's just sometimes hard to understand the rate and the scope of the changes we're experiencing. And to also acknowledge that not all of any given winter's anomaly is due to global warming or due to anything else. It's just like the wildfire question or the heatwave question or the hurricane question. Is climate change the only reason we've seen changes in the extreme iterations of these phenomena? No. It's one of multiple contributing factors, others of which can just be bad luck, random natural climate variability, and stochastic weather. But there is a climate change signal baked into these things, and in some ways, a record warm winter and a record snowless winter are some of the single most obvious, unambiguous indicators of a warming climate in the American West that I can possibly think of. Okay, I think it's time for me to wrap this one up. So thank you for joining again. I will probably I don't know when I'm going to have time to write it, but my goal is to write a Weather West blog post in the next 24 to 48 hours, get it out, regarding this exceptional and likely record breaking heat wave in the Southwest that will last for days and potentially extend across really the western third of the entire country, all the way into the Rockies, inducing a rapid, early, unprecedented early snowmelt in a season when we really didn't want to see that. No miracle March on the horizon. I reserve judgment regarding potential for an awesome April, but I'll just point out that the seasonal outlook does not support a particularly cold or snowy April, and even then, it's essentially impossible for April to make up for what March at this point is clearly not going to bring. It just isn't in the statistical cards, so this is going to be a big story. The lack of snowpack, the high elevation mountain forest wildfire risk, and of course the extreme heat, genuinely extreme March heat, all the way up into the 90s and 100s in some locations later, either this week in parts of Southern California or into next week for Northern California and the rest of the West. Thanks for joining, and see you next time.